Okay, lesson today is heat transfer. So the first thing I want to talk about when I talk about heat transfer is I want to do a reminder of two terms. They are endothermic and exothermic, because they're important from a heat transfer standpoint. Okay. So what happens with endothermic is that you have to think of it in two ways. You have a system and you have what we call surroundings. Okay? Now, exothermic is the easier one, so why don't we do that one first? When I think of exothermic, I see the word exo and I see the word thermic. And so exo, what I think of, or actually let's start with thermic, is I think of heat. Exo looks like the word exits. And what does it exit? It exits the system. So, an example of somebody's exothermic would be, you have a flame, right? And you're, out here trying to warm your body. Well, what happens is heat is exiting the system to go to you, right? So as such, that's considered to be exothermic. Endothermic, on the other hand, what you have is you have heat entering into the system. Now this one's a little harder for us to think about, but the best example I have is refrigerator. What ends up happening is this. The refrigerator itself absorbs the heat. So if you ever go up to your refrigerator, you feel around the outside of it, it's actually relatively warm. And what does it do? And so why does it do that? Because it's absorbing the heat. The heat enters into it. What is the byproduct of that? The surroundings or the things inside the refrigerator get cooler. Now, that whole idea is related to something called heat transfer. And there is an equation that we can use to symbolize it. And that equation is this. Q equals M delta T CP. Now, what do these things mean? Well, they mean the following things. Q is a measure of heat. So Q stands for heat. That's going to be measured in one of two ways. You're going to measure it either in calories or in something called joules. The SI unit is joules. M stands for what it's always stood for. It stands for mass. Delta T is change in temperature. And then this last thing is called CP, and what it's called is specific heat. Now, when we do problems involving this equation here, the most important thing is this. Your CP is going to be measured. I'll look at number one. It says, remember the specific heat of water is 1 calorie per gram degree Celsius. What you have to remember is this. If this thing says calories per gram degree Celsius, then your Q must be in calories. Your mass must be in grams, and your temperature must be in degrees Celsius. Now, I've only seen this expressed two ways. Calories per gram degree Celsius or joules per gram degree Celsius. So in that case, the mass is still in grams, temperature is still in degrees Celsius, but the heat here would be in joules. So there's a conversion that is helpful to us. And that conversion is, let me make absolutely sure I'm right. Yeah. 4.18 joules equals 1.00 cals. I would just get to know that conversion just in case you need to make that happen. All right, because it has to be equal. All right, let's do some problems together. So we'll start at the very beginning with number one. It says, how many calories of heat are required to raise the temperature of 550 grams of water from 12.0 degrees Celsius to 18.0 degrees Celsius, remembering the specific heat of water is 1.00 calories per gram degrees Celsius. So here we go. Q equals M delta T CP. Well, it says how many calories of heat, so it wants to know Q, is equal to 550 grams change in temperature. What the change in temperature was is it went from 12 degrees Celsius to 18 degrees Celsius. And what I would do with delta T always is I would take the T final and subtract the T initial. What do I mean by that? Well, it tells you it's going to be final of 18 degrees. So that's 18.0 minus 12.0, and it's degrees Celsius, times 1.00 calories per gram degree Celsius, right? So two significant figures, when you do this, you're going to get 6.0 degrees Celsius and 1.00. 2 degrees Celsius, 2 significant figures, 2 significant figures, 3 significant figures. Therefore, your answer can only have 2 significant figures. When you do the math on this, you get 3,300. Now, this is Q, right? So it's either going to be measured in cals or in joules. Well, here, this one is measured in cals. Remember, everything has to match. Grams match grams. Degrees Celsius matches degrees Celsius. Calories has to match the Q. So this is 3,300 cals. Let's do number 2. Because there's a tricky part to number 2. Number 2, it says, is how much heat is lost. So we're still solving it for Q. When a 640 gram piece of copper cools from 648 Kelvin to 299 degrees Kelvin. So 648 Kelvin. Well, that's going to be a problem, okay? Because it goes from this to 299 Kelvin. And the reason that this is a problem is because it's in Kelvin, but if you look at your specific heat of copper, it's in joules per gram degree Celsius. So what you have to do is you have to take this and turn it into degrees Celsius. So I always remember that K equals 273.15 plus degrees Celsius. So I have to do a little bit of algebra real quick to make this degrees Celsius equals K minus 273.15. And now I just plug in these two numbers. So this becomes 648 minus 273.15. And this one becomes 299 minus 273.15. I'm going to stop the film for a moment. I'm going to do the math on these two calculations. Alright, so I did the math here. 374.85, 25.85. So I just told you T2 minus T1, right? So this is T2, this is T1. When you subtract 374.85 minus 25.85, the temperature that you get is, I think, 349. Yeah. So 349 degrees Celsius. That is a negative 349 degrees Celsius. Now, hundredths place, so 0.00 degrees Celsius. So now, we can keep doing our problem. We tell you that you have a 640 gram sample. 640 grams. Then, negative 349.00 degrees Celsius, right? And that's times a specific heat which was given to you in the problem of 0.38452 joules per gram degree Celsius. you do the math on this. 2 significant figures, 5 significant figures, 5 significant figures. You can only have 2 significant figures in your answer. Therefore, the answer is negative 86,000 joules. Or I suppose you could have also said negative 8.6 times 10 to the 4 joules. Note, joules matches joules. Grams match grams. Degrees Celsius match degrees Celsius. All right, let's do now question number 1 of the second set. It says how many grams of water would be required? So grams of water would require 2.20 times 10 to the 4 calories of heat to raise this temperature 307 to 373 Kelvin, right? Remember, the specific heat of water is 1 calorie per gram degree Celsius. So Q equals M delta T Cp, right? And here we want to solve it for M. Well, you're told that you have 2.20 times 10 to the 4th calories of heat. That's the Q. You want to solve it for M. Delta T, which I've already done, is going to be 66.00 degrees Celsius. 66.00 degrees Celsius. The temperature goes up. Now here's the weird thing about this. Yes, this is positive. We're talking about mass, aren't we here? So even if the temperature went down and this was negative, would it make any sense to answer a mass question with a negative answer? No, right? We're not dealing in antimatter. So because of that, this is going to be one of those times where you do that absolute value thing and think about, does my answer make sense? Okay? You're given a CP, and that CP was 1.00 calories per gram degree Celsius. So you ask yourself, do your units match? Calories matches calories. Grams will match mass. Degrees Celsius matches degrees Celsius. M equals, you do the math. 3 sig figs, 4 sig figs, 3 sig figs. Therefore, my answer is allowed to have 3 significant figures. 333 grams. Flip it over. Let's do number 1 on the back. It says, how many degrees would the temperature of a 450 gram ingot of iron increase if 7,600 joules of energy are applied to it? The specific heat of iron is 0.4494 joules per gram degree Celsius. All right, so here we go. Q equals M delta T Cp. All right, so you were told the heat, it says it increases 7,600 joules. No decimal, 2 significant figures. The mass, you were told, is 450 grams. No decimal, 2 significant figures. You want to solve this for degrees of temperature change. That's what delta T means. And you're given a CP of 0.4494. And it's joules per gram degree Celsius. Do your units match? Joules matches joules. Grams matches grams. Your degrees Celsius is gonna match here. You solve this for degrees of temperature change, and you get 38. Now you're allowed 2 significant figures, so it's 38 degrees Celsius. So there's a couple more examples.